Hello everyone, thank you for joining our presentation today. I'm Clark Zoeller, I'm a sales engineer with LiveAction. Today's webinar is on how to manage voice, video, and business applications using the LiveAction management solution. So the agenda we're going to follow is this brief introduction, and we're going to dive straight in and show you exactly how we can use LiveAction to protect our critical applications in our network environment. So I'm going to shift gears and I'm going to bring up a copy of LiveAction. And if you have not seen LiveAction before, what we're looking at is a network map. And on this network map, it's comprised of larger circles, and these larger circles represent the routers and switches that are being managed by the tool. If I zoom in with my mouse wheel, the smaller circles within the larger circles are the device's interfaces. And if I really zoom in, I can see the real-time bandwidth measurements that are passing through each interface. Now, as I zoom back out, what I want to highlight here is this network map that we're looking at was drawn for us automatically by LiveAction. Now, we as the engineer have the ability to manipulate the map and can interact with the map. We can move and organize each element in the map in any way we see fit. And we encourage folks to build a mental model of their environment. So by having a mental model, what we have found is that brings much quicker problem resolution as, say, you're deploying QoS or troubleshooting application performance with a tool like this. And then finally, everything in LiveAction is color-coded. So if you notice in this example, 3 of the devices are green. Green is good. But 2 of our devices are amber. And that's our way of showing you that they are congested or have some sort of performance issue. If I zoom in with my mouse wheel, I can see that the interfaces in this example are amber, and those are performance issues we're going to want to take a look at in just a couple moments. So LiveAction is not just a mapping tool. We are also a NetFlow collector, and something that's very unique about LiveAction is we can paint an end-to-end picture of the traffic flowing through your network environment based off our flow technology. Now, right now, I'm looking at multicolored arrows passing through the network environment, and each color represents a different application type. So we can see that red is internet, yellow is voice, blue is video, and so on. And what's so powerful about this is I can use our filtering mechanism in LiveAction to look at just very specific conversations that I'm interested in. And so what I'm going to do before I filter in on any conversations, I'm going to change my display colors to that of DSCP values. So now the applications I'm looking at are from the perspective of DSCP priority tags. So I'm looking at the priority level of each application, so each color represents a different priority level in my network. Now let me implement one of those custom filters I mentioned, and I'm going to focus in on just a subset of the traffic passing through my network environment. Here it is. And what I'm looking at is, let's say this was an example of maybe a remote site connected over an MPLS cloud, and we're looking at a set of remote site users that have voice over IP phones. And let's assume that these voice over IP users are having call quality issues. Well, what I can do with our flow dynamics is I can click and highlight one specific conversation through the network. I can see that conversation is passing through green interfaces on the first hop. That's good. It's passing through an MPLS cloud. And then the next hop is an amber interface. That's, again, one of those interfaces that's having a performance issue. And to investigate what's happening there further, all I have to do is double-click on that interface. I'm now going to go to the QoS tab, and I now see the real-time performance statistics of this interface. So let me describe what we're seeing here. So to the top of the screen in this bandwidth graph and table, I see the in-bar data that's being collected by this device's interface. So this is where our Cisco device is doing a deep packet inspection, and we are understanding via SNMP what are the applications that are passing through this interface. And then the bottom half of the screen in this current view is that of the CBQS MIB. This is an actual graphical view of the QoS policy itself. Now, most importantly, because of our interface was amber in the map, notice how in the QoS table view here in the bottom right quadrant, the CZ VoIP class is amber. That's a voice over IP queue, a priority queue, and that's definitely a performance issue that LiveAction is visually warning us about. So what I'm going to do, I'm going to right-click, and go to View Class Statistics. And what I now see in this queue's real-time bandwidth graph is that it is actively dropping data. I can see that based off the red line in the graph. And what is so powerful about LiveAction is not only will we visually show you where there are performance issues, but if I right-click and go to Adjust Output QoS, LiveAction gives us a GUI that will allow us to configure and fix this QoS issue on the fly. So what I'm looking at here is our Adjust Output QoS policy wizard, and I can see a summary of the QoS policy on this interface. So I can see the class names, the queue types, the bandwidth reservations, etc. I can interact with any of these drop-downs. I can also see that there is a traffic shaper on this link. And then to the bottom of this view in this pie graph, I can see a percentage breakdown of how bandwidth has been allocated to queues. Notice how 84% of the bandwidth is still available for use by the queues. And if I look up to the top of this screen, looking back up the CZ VoIP class, notice it is a priority queue, but someone misconfigured that with only 8K of data, and that's obviously probably a configuration issue. Someone misconfigured that, so I'm going to change that to maybe make that a better number for today's example. I'm going to make that 1024K. Notice how our pie graph updated appropriately to help us understand that. I'm going to click Preview CLI, and what's happening in the background is LiveAction is creating the appropriate CLI configuration for me. So for me, I don't ever have to go to the command line with LiveAction to fix and update this policy. I'm going to click Save to Device. LiveAction is now going out, logging into the device, and pushing that QoS configuration we just saw it create. I'm going to close this screen. No, I won't say anything to the startup config. And in just a couple moments when SNMP catches up, let's see if the behavior of that VoIP class doesn't change. But while we wait for SNMP, I'm going to turn your attention to our red alert button at the bottom left of my screen. What I'm now seeing is a list of all of the real-time and alerts and alarms that LiveAction is generating. In this list of alerts, we're going to see several QoS alerts. Well, actually, if we drill down in here, we'll find where my priority voice queue was dropping data. We can also receive QoS alerts based off when a specific queue crosses a bandwidth threshold or an interface crosses a bandwidth threshold. We're seeing several IP SLA alerts, like maybe jitter tests that are failing, for example. We're also seeing alerts based off of net flow data. And LiveAction is very unique in that we can paint an end-to-end picture of your environment and also collect the application performance statistics of those applications. And via our alerting mechanism, we can warn you about when your applications are having performance problems. Now, all of the alerts that we see in this screen can be sent to you in either an email or a syslog message. So quite literally, before your end users ever complain about network, voice, video, or application performance issues, you could have been notified about those type of problems from LiveAction. I'm going to close this screen, and now that I'm back to our real-time interface view, notice how our CZ VoIP class is no longer amber. If I right-click on it, go to View Class Statistics, I can see the red line indicating the drops that was happening in that queue. It's now flatlined to 0. That looks good. I can also see in the bandwidth graph that the pink color equating to my CZ VoIP class is now utilizing a lot more of this interface's bandwidth. That looks good. If I come back to my home screen, go back to flow, I can again track one of those voice calls through the network, and I can see it's now passing through all green interfaces all the way back to the source. So I know I have no congestion, no interface drops, or any queue drops. So that's looking good. I'm going to click and let's look at all of the arrows passing through this network segment. And notice how in this example, these arrows passing to this voice over IP subnet are all light blue, and that stands for best effort. So that means even our critical voice over IP traffic is being marked with only best effort, and in turn, our infrastructure will most likely, especially our service provider, treat that VoIP call as just a best effort application. That's definitely a QoS matching and marking configuration issue that we want to fix, and LiveAction can do that for us very simply. So what I'm going to do is I'm going to double-click on that first hop device and go to my QoS tab. I now see a list of the interfaces that LiveAction is managing on this device. I also see where LiveAction discovered a handful of QoS policies that are in place on these various interfaces. I'm going to click and highlight the input side of VLAN 12. That's the interface closest to the source in our example. Notice how it does not have a QoS policy on it. And LiveAction has a couple ways to fix this. One of the ways that we could fix this is we could create a QoS policy from template. So built into LiveAction, we have a handful of QoS templates, and they're all based on Cisco best practices. And what we're doing is we're parsing this device's config. In a moment, we'll be able to select our advanced templates. Here they are. I'm going to click Next. And what we're going to see is a list of those QoS templates built into the tool. So whether your network needs an 11 class QoS model that would match, mark, and protect your voice, your video, your high priority data, that's here. Or we could go with maybe, say, the latest 12 class Cisco Medianet model. That's also available and built into the tool. Or maybe you just need a very basic 3 or 4 class QoS model that might just protect voice over IP, for example. All of these templates are built in the tool. You can deploy them right out of the box. Many of our customers will either use these out of the box, or these will become the starting point of their own custom QoS policies. And that's actually what I'm going to show you in my example here is I'm going to have LiveAction go out, discover a list of all of the QoS policies it finds on this device, and I'm going to select a pre-canned policy that I've made by hand via the tool, and we're going to deploy that policy into the environment. And I'm going to select the set DSCP policy here. I'm going to tick to apply it to the input side of VLAN 12. Click OK. LiveAction is going out and pushing that QoS policy for me. And that simply, I've now updated my QoS configuration. Now, in just a second, when we see that policy has been applied, I bet you're like me. I came from the command line world. You probably want to know what it is I just did when I pushed that policy. Well, if you really wanted to, you could right-click on VLAN 12, go to Statistics, and Show Interface Details. Yes, LiveAction can parse the CLI and show you exactly what's happening there if you really wanted to. To the top of this screen is the physical layer statistics of this interface. To the bottom is the statistics of the QoS policy that we just applied. And what I hope to show you in our time today is we no longer have to scroll through these potentially hundreds and hundreds of lines of code to understand both the configuration as well as the performance of our QoS policies. And what I mean by that is I'm going to right-click on my 2921 device, go to QoS, and then Manage QoS Settings. Built into LiveAction, we have a GUI that will replace the need to use the MQC in your iOS. With this GUI, you'll be able to create QoS policies, edit existing QoS policies that LiveAction discovers, as well as you can deploy QoS policies from this GUI. Let me show you what I mean by this. So in this dialog window, I see a list of the QoS policies that LiveAction discovered on this device. If I click and highlight that set DSCP policy, I can see that it is applied based by that little green check mark beside it. I can also see a summary of the configuration of that set DSCP policy here in our GUI. If I click on the VoIP class, for example, I can see under its Classify tab, here's the match criteria that makes up that class. If I click on the Marking tab, here I can see where the DSCP value of 46 or EF has been applied to my VoIP class. Now, let's say I wanted to edit or update this policy. Maybe I wanted to add a new classify type or application to my VoIP class. Well, all I have to do is click my Edit button. I'm now in my Class tab. Under the Match type, I just need to select a different match criteria. I can match based off of access lists. I can match up DSCP value, protocol using INBAR. I could even match up the latest INBAR version 2 groups. And maybe in this example, I will select an INBAR 2 group. Maybe I'll select this peer-to-peer technology group. I'll click Add Match Statement, and in this peer-to-peer technology example, since it's an INBAR 2 group, all of these protocols that get rolled up into this one P2P technology group will now be recognized and put into my voice over IP class with that simple change. Now let's say I want to create a new QoS policy from scratch. I can definitely do that too with LiveAction. I'm going to click the Add Policy button. I'm going to name my policy Test. And here's that new test policy I just created with the class default already assigned. If I want to assign a class to that test policy, all I have to do is right-click on it, go Add Class to Policy, and then select a class that LiveAction discovers. Here's a list of all those discovered classes. I'm going to select this video class and click OK. Now that video class is assigned to my new test policy. Notice how in the Classify section, the marking or the matching statement was already applied for me. I never had to reinvent that wheel with LiveAction. In this example, actually, I'm going to remove my video class. And since the class default is highlighted, I'm going to click on the Shaping tab, and I'm going to select Shape Average, and I'm going to put in a value of, let's say, that. Now I've assigned a traffic shaper to my class default of my test policy. And if I wanted to make this a hierarchical or two-tiered policy, all I have to do is click, drag, and drop another policy on top of the class default. And that simply, I now have a hierarchical policy in place. LiveAction also does have a hierarchical policy wizard where I could have set that parent, class, and child policy relationship as well. And then most importantly, let's say this test policy is going to become a new corporate standard that I want to roll out to the rest of my environment. Well, if I click this icon here, our Copy Policy to Devices icon, all I have to do is go find that test policy in the list and then just tick which devices I would like to push that policy to. Now, LiveAction will intelligently push this policy if I was to click OK, and it will check for any conflict. So let's say I click OK, I push my test policy, LiveAction finds a conflict. It will warn me about that conflict. I can either skip or overwrite the change. If I do select to overwrite the change, quite literally the test policy as we see it here in the screen behind me is exactly the configuration that will end up on your far-end devices, including any access list that may be tied to this policy. They will also get pushed. So managing as well as ensuring you have consistent and uniform QoS policies throughout your network can be that simple with LiveAction. So I'm going to close this screen, and remember how we'd gotten here. We had implemented that set DSCP policy on the input side of VLAN 12. If I go back to my home screen, go back to flow, remember how end-to-end we were seeing all light blue arrows indicating just best effort? I'm going to click refresh. We're going to parse our flow data in our map, and here we now see both red and blue arrows passing through the network environment. Red stands for EF, so this shows us that our high priority voice over IP traffic is being matched, marked, and honored all the way through the network, even over this MPLS cloud. So this is exactly what we would want to see for your critical voice, video, or other high priority data, something similar in nature to this. So this is good. But let me show you an example that is broken, for instance. I'm going to change my filter, and I'm going to implement a custom filter using our search capability in LiveAction. Think of this search string similar to what you can do in Wireshark. Same concept where you can have very complex and and or logic if you like. But it's a very flexible and easy way to focus in on just specific conversations in the network. So I've just implemented a custom filter, and what I'm looking at now happens to be another voice over IP call passing to the network. And notice how I see both, in this case, light blue as well as red arrows passing through the network, but the red arrows are not being seen passing all the way through. They're being lost somewhere in this cloud. So here's a visual representation of a end-to-end QoS configuration issue in our network that LiveAction that simply has shown us exactly where the problem is. If you tried to manage this issue the traditional way, you would have to put probes throughout your network. From my personal experience, trying to find issues like this can sometimes take days or even weeks, depending on change control policies within certain organizations, where with LiveAction, point, click, and immediately you understand exactly what's happening from that quality of service perspective. Now, what's even more powerful about LiveAction is not only will we show you the matching and marking policies of a conversation like this. This happens to be a G711 call we see passing through the network. We can also do several other quite amazing things now. So the way LiveAction is showing you this end-to-end picture is via traditional NetFlow. LiveAction also supports other types of NetFlow templates, and Cisco has now started to add very advanced deep packet inspection to both their routers and switches, and via NetFlow, they will send LiveAction the application performance metrics that they collect. And what I mean by that is this, is I've clicked on our table tab, and what I'm seeing is the exact same data that's in the map behind me, just in a table format. And notice I'm on the basic flow tab. That's our way of indicating traditional flow. I'm going to come to the Medianet tab, and this is an advanced Cisco technology where our routers and switches will do a deep packet inspection. They'll understand the performance of voice and video calls as they pass through their backplanes, and then send LiveAction that performance data. And what I'm seeing in this view visually is that one of my VoIP calls, or the VoIP call we see on our screen behind me in this example, is having very high packet loss. I'm being warned about that based off that red cell. Now, if I right-click on that specific flow and go to Show Medianet Flow Path Analysis, LiveAction is very unique in that we will show you a hop-by-hop perspective of how this one specific call is performing in your network. I'm going to click Show Path so it even becomes more visual. And what I'm seeing here in the table view is the first hop that we have highlighted in green. The application is appearing to be performing well from that device's perspective. But notice how we are warning you about the correlated QoS information on this first hop. We see in amber that the output QoS policy on that first hop is having a performance issue that this call is passing through. And the next two hops we're seeing highlighted in red. And that shows us that the call is having performance problems. In this case, it's having very high packet loss, and we're warning you about that. So visually, you can understand exactly how this call is performing, and you can cross-correlate that with how the network is performing, and in turn, how the QoS policies are performing. We can do this in both real time as well as we can do this back in time, and we're going to get into that a little more here in a couple moments. But this is an extremely powerful tool because think about, typically you will have a voice over IP issue. Your end users will finally bubble up that issue and that trouble ticket to you, but it may be later that day or 3 days ago before you finally understood about the problem. So by being able to go back in time and know exactly how your network's performing as well as how all the calls passing through your network are performing based off net flow data we're collecting from your environment, you can pinpoint exactly what was the root cause of your voice and video issues using our Medianet flow path analysis. So I'm going to turn our attention a little bit. Instead of looking at just voice and video applications, let's take a look at some critical data applications and show you how LiveAction can help you manage the application performance of them. And so what I'm going to do is I'm going to refresh my screen. I'm actually going to remove that custom display filter so that we see all the data passing through the network environment again. And what we're going to be looking at is a technology called AVC, or Application Visibility and Control. And this is our Cisco devices that support INBAR version 2. That would be ASR 1000 platforms, ISRG2s, the 4451 router type. They all support INBAR version 2, and in turn they support AVC. And what AVC is it's our ability to track the performance of critical data, or TCP applications. Let me show you how we can get to that data and make more use of what I'm speaking of. So right now I'm looking at a map view of my infrastructure. I can visually see my flow data that's passing through my network. If I double-click on this device, I will see the raw or the real-time flow information we're collecting on this device. Right now, I'm looking at the basic flow type, so this would be traditional net flow. So to the top of the screen, in this table view, I can see all the raw flow statistics. To the bottom of the screen, I have a graphical representation of this one device, and in real time, I can see what flows are passing through which interface. I'm going to minimize that graphical view so we can focus on the table view. Since we're looking at the basic flow tab right now, what we're looking at is all the traditional flow data that we're used to seeing for the last 20 years or so. So we can see source and destination IP address, source and destination port number, input-output interface, the DSCP value, or the quality of service priority tag on the traffic. If I keep scrolling over to the right, I can see things like the bit rate. That's the throughput measurement as determined by the infrastructure device itself. LiveAction isn't computing that, etc. Now, there's a column here that I want to highlight, the application column. This device happens to be running flexible NetFlow version 9. That's the latest NetFlow configuration methodology. And something very powerful about that is when the flow data is sent from that Cisco device to LiveAction, pre-embedded in the flow record is what application was found from the in-bar application recognition engine that's embedded in your Cisco iOS. And so here we can see where the iOS discovered things like Skype traffic, YouTube traffic, here's some SIP traffic, some Citrix traffic, etc. So pre-embedded in the flows are what applications are passing through the network. This is great, especially at a glance, to understand what's happening in real time, as well as having this data populated in our historic reports really comes in handy and helps streamline the troubleshooting process. I'll show you more about that here in just a second. But what I was talking about just a moment ago was AVC, or application visibility and control. I'm going to come to this drop-down change from basic flow to the AVC flow type. And again, this is where we will be tracking the performance of TCP data as it crosses through this device's backplane. And so what I'm seeing here looks like fairly traditional flow information here to the left. But over to the right, I'm seeing columns that talk about things like retransmissions, and we can see in red where LiveAction is warning us about performance issues. In this case, I'm seeing warnings about high retransmissions. The ND column is network delay, and we're actually being warned about some high network delay in this example as well. The CND client is client network delay, SND is server network delay, RT is response times, AD is application delay, etc. So we now have extremely granular understanding of what was the performance of the application itself. And our Cisco infrastructure is doing this. We don't need any taps, probes, or other network equipment to pull this off. Your network that you already have in place can now bring you these types of statistics. Now, let me show you how to make the best use of this. Let's do it from a historic report point of view. I'm going to go to Reports and Flow, and I'm going to run an AVC report. I'm going to run maybe a top application performance report, and I'm going to execute that report. And what I'm going to be seeing is the top applications passing through, in this case, that same 2921 device I was seeing in real time just a moment ago in the screen behind me. Here's a list of the applications passing through the device. I'm going to click and highlight, say, the Citrix application. I can see its application delay, client network delay, server network delay measurements, etc. If I right-click on that and go to View Application Over Time, this is, again, something that's extremely unique that we can now pull out of your network environment using LiveAction. And it's this. I'm going to be showing you the client delay in amber and the server delay in blue. If I scroll back up to the top of my screen, I can see the client and the server delay mapped out for me. If you notice, our client and server delay are coming in under 3 milliseconds for my Citrix app. That looks good. But imagine with me, what if we saw our blue server delay lines peak up to like 1.5 seconds or 2 seconds? Maybe it's a database server that needs to be re-indexed. Well, using AVC, we can now understand what is the application performance as your critical data passes through the network, and you'll have a clear indication of, was it the client side, was it the server side, or was it the network that was really at fault. Now, another great byproduct of the AVC technology is that the HTTP URL and URI statistics of the conversations passing through our infrastructure can now be gleaned. And what I mean by that is this. Notice how I'm running a AVC HTTP report, and I can see what are the top websites that are being hit, and this is being done based off of maybe a WAN router sitting on the inside of your network. You can now know what traffic is passing through destined to the internet, for example. You no longer have to rely on internet-based proxies or internet firewalls, etc., to glean these type of stats. You can now know it internally. So that can be an extremely helpful view of what users are doing in your network. Another key about LiveAction's reporting mechanism, since we're on the reporting page, is that we always keep our data on disk in the raw. And let me show you why that's so powerful and important. I'm running a application report. I'm going to do that for all devices in my network. And so what I'm going to be seeing is all of the flow data passing through my network, and I'm going to be able to see and determine who was the top application. Notice here how I'm seeing that in both a time series report. There's a bandwidth graph. I also have a table view of all of the applications passing through the network. I'm going to select, say, this RTP application. It's the second top talker in this example. I'm going to right-click on this, and since we have all of the data in the raw on disk, I'll always be able to go back in time and pull off what I'm getting ready to show you. As long as you give us the disk space, we can show you the views I'm getting ready to show you. So I'm going to drill down on my RTP traffic, and I'm going to run a DSCP report. So RTP is voice and video conversations passing through the network. Here I'm seeing where my voice and video traffic is being marked as best effort, EF, and CS4. While EF and CS4 are traditional DSCP priority tags of voice and video traffic, but notice how the majority of my voice and video traffic passing through my network is being marked as just best effort. Most often that is exactly what we do not want for our voice and video. We want it to be marked with high priority, so in turn our QoS policies will treat it as high priority. Well, what I can do with this is I can drill down on that best effort traffic and maybe run an address pair report. And now I can further understand who is the RTP traffic that is only marked as best effort. And here is a list of those users. Now I can go track down those users and figure out why they are not marking their data with high priority as we would expect. So with LiveAction's reporting capabilities, you'll always be able to go back in time as long as you give us a disk space and know exactly what was happening in your environment. We can do this for the last 15 minutes, hour, 6 hours, day, or some custom time period. So let's say 2 weeks ago on Tuesday, 2 p.m., you wanted to know exactly what was traversing your network. You could do that. Now, all of the historic reports we have in LiveAction can be saved and scheduled, and we can schedule our historic reports nightly, weekly, or monthly. And when you schedule a report, it can be emailed to you for easy dissemination. You can have it emailed to you as a PDF or just as a link that will allow you to quickly log into the embedded web dashboard that's part of the LiveAction server so that you can gain access to historic reports. Another great feature about LiveAction's historic reporting mechanism is our ability to create our own custom reports. So pre-canned in LiveAction, let's say there are around 50 reports that we already have pre-created for you, but let's say for whatever reason they don't meet your needs. Maybe your management wants to see the data formatted in a different way than is pre-canned in the tool. Well, with our custom creation abilities, we can base our reports on any NetFlow v9 or IP fix index header. So what I could do are things like this. First, I'm going to name my report. I'm going to call it Clark, and maybe I'll so 9988 is its name. And maybe in this report, I just want to see what's the source port, source DSCP value, and source IP address of the traffic that I'm going to be looking at. I'm going to be looking at in the inbound and outbound direction. I'm then going to resort my column headers to be the way I like. Maybe I'll do something like that. I'm going to click Create Report and then Execute Report, and now I'm going to see the data in the format that I just requested, and that simply I can have a custom report in just the way I want. Good stuff. So let me revert back and let's talk more about what we can do from a QoS perspective, because the roots of LiveAction was actually to be a QoS tool for the military. Quite literally, so a combat network operator could sit on the back of a Humvee and in battle zone conditions be able to control QoS. So what I'm going to show you is this. I'm going to go back to our home view, and I have a network that I am managing with LiveAction, and maybe I'm just getting started with QoS, or maybe I'm a consultant, I'm walking into a new network and I want to understand where's QoS been deployed in our environment. Well, LiveAction has built into it a QoS audit capability. And the way we do what we do to manage, create, edit, and deploy QoS policies throughout your environment is we actually have a copy of your CLI's configuration. And since we have a copy of the configuration, we can run analytics on that configuration, and we can pull off this audit, and we can show you in a summary where's QoS configured in the environment, where is a list of devices that have QoS issues that we may want to investigate. If I was to come to the Policies tab, for example, I can see which devices LiveAction is managing, what policies are on which devices, as well as which policies are applied to which interfaces. We can also drill down into the details of each policy from here. If I click on the Issues tab, LiveAction will actually compare your QoS configurations against Cisco best practices. We think of it quite literally as having a CCIE built in the tool that's going to watch over your QoS configurations and help you out and let you know when you may have performance issues with your configurations you may want to know about. Another QS item that we want to highlight and mention is this. Notice how in real time I'm looking at this device and I can see that this interface is amber, indicating there's a performance issue with this interface. If I drill down on this interface, go to my QS tab, I can see the real-time performance measurements of what's happening with this interface. Now, if you notice in this example, I can see that the interactive video queue is having a performance issue. I can always right-click, go to View Class Statistics, and see exactly what is the drop rate that was occurring. Why is that queue amber, for example, and know exactly what's happening in real time. But we also have historic QS reports as well. And just like we could do with NetFlow, we could always go back in time and show you exactly what happened in your network environment, just like it was happening in real time. So let's say 2 weeks ago and Tuesday at 2 p.m., I want to know exactly how one specific queue of my environment was performing. I can do that. So what I'm going to show you is how I can drill down on this graph. Maybe I'm going to focus in on my interactive video queue, for example, and I can see exactly what was the throughput of that queue at any point in time. And we're always going to be able to drill down and show you exactly like it was as we collected it. So from a capacity planning perspective, you'll know exactly how all your QS policies are performing. Another thing that we have built into the LiveAction that's extremely helpful is that of our dashboard. I'm going to access our dashboard here from the dashboard icon, and I'm looking now at the System tab of our dashboard. And what I see here is the top 10 events that I may want to know about in my environment. So here on the System tab, I see my top 10 CPU memory utilization of my infrastructure I'm managing. I see my top 10 interface bandwidth and interface drops. I also see a WAN site dashboard where at a glance I can understand how are my WAN links performing based off their logical capacity. That's important. We have that. We also have the ability to drill down into our alerting mechanism from our dashboard. So here I can see a list of the top alerts that are highlighted in LiveAction. I can say right-click on my QS alerts and say show alerts, and I can drill down and do a historic search on the QS issues occurring in my environment. And what I will then be able to do is I will be able to then see a list of all of those alerts, and I could then right-click on one of those alerts and say Open Report, and then have access to the applicable historic report that indicated why did I get a QS alert and know exactly what happened back in time, just like it was happening in real time. For example, in this specific report, I'm looking at a pre-policy post-policy report. So this is showing me what is the volume of bandwidth before it hit the QS engine, what's the volume of bandwidth after it hit the QS engine. I can do this per queue. So you'll have a very granular understanding and a very easy workflow to easily make sense out of all the thousands or millions of conversations or alerts and alarms. You'll be able to drill down on exactly what it is you care about in your network with this dashboard. Here we are on our QoS dashboard, and the same principles apply where we see our top 10 input and output bandwidth by class or queue, input-output drops. Again, each one of these elements that we're looking at are things we can drill down on. For example, I could right-click, drill down, and run a pre-policy, post-policy drop report. So now I'm seeing why was this specific QoS policy on my top offender list, for instance. I could drill down and see exactly what is the drop rate of a queue. In this case, I'm showing you the drop rate of a voice over IP queue. So by having this data, I can always drill down and know from a capacity planning perspective how much or what size would I need to increase this voice over IP queue size to be able to adequately handle the bandwidth that it is trying to utilize. Then we also have a NetFlow dashboard where you can see at a glance who are the top 10 talkers in your environment. I could, of course, drill down on any one of these talkers and run the applicable historic report there. I can also see from an AVC and Medianet perspective. Again, those are the NetFlow technologies that allow me to understand application performance metrics. Here we can see who were the worst offending calls in my environment, either from a jitter or packet loss perspective. What were the worst performing TCP critical data applications? I can drill down and understand those things as well from this dashboard view. So what I'm going to do now is I'm going to shift gears a little bit. Let me tell you some more about the other features available in LiveAction. And the first thing I'm going to show you is our routing tab. And what's very unique about LiveAction is the way we draw the map is actually by parsing the routing tables of your devices. That's how we're drawing this map. And we're doing this the safe way. We're actually taking a copy of the CLI's IP route command. We're not doing this via SMP. We're doing it the safe way there. And a byproduct of this, something that's very powerful that we can do, is I'm going to drill down on this device I've annotated. I'm not really managing this device here per se. It's just an annotation as a highlight of an important network element I may want to visualize in my map. I'm going to right-click on that device and say Use as Source. And notice how the source field populated for me. I'm going to right-click on this device I've annotated as an iPad and say Use as Destination. See, that's filled in. I'm going to click Show Return Route Path and then Show Routes. And what I'm now going to do is show you the bidirectional path that this specific conversation would take in my network. And in this case, what I'm visualizing for you is asymmetric routing is occurring. And that simply, I can understand those very complex concepts at a glance. As well, on our routing tab, we have a protocol tab. And a great feature we have in our protocol tab is the ability to track the adjacency table relationships of your routing protocols. And so visually, I'm understanding, in essence, the hello messages or the routing protocol adjacencies, and I know that everything is performing well based off the green color in these arrows. If anything was to change, maybe I have a outage and my routing protocols reconverge. Of course, the color code here will change as well. We can get an alert and an alarm, and you can be notified of not only when did that outage happen, but when was service restored. We also have an IP SLA tab, and this is a great feature to very quickly deploy as well as understand any IP SLA test that LiveAction discovers in your environment. And what I'm looking at here to the top of the screen are some traditional IP SLA tests. If memory serves me right, these are all jitter tests. I'll actually click and confirm that. Here I'm looking at the real-time performance stats of these tests. I can see that they're jitter tests. I can see things like the latency, jitter, packet loss, MOS score of those tests. And I can also visualize what is the performance of the test by the red, amber, or green color of the tests themselves. Another feature built into LiveAction is our quick test mechanism, where I can very easily deploy more IP SLA tests. So here I'm selecting my 1811 device. I'm going to make it another jitter test. I'm going to select my source interface. And for the destination field, all I have to do is use my mouse, click on another interface in my map, and it will auto-populate the destination field for me. I don't have to go scramble and look that up. If I click Save to Device, we'll push that new test. That simply, I can click and deploy an IP SLA test. Now, to the bottom of the screen, we have some more IP SLA tests, but these are a special type of test. They're relatively new. They're called IP SLA VO, or Video Operation Test. And what these are is our Cisco devices, both routers and switches, they can quite literally stream RTP video-like conversations through your network. And you can use these to stress test your environment and understand, is your network ready for a video deployment? How many video calls can you really get down that WAN link, for example? These are the types of questions you can answer with these IP SLA VO tests. And so what we're looking at is the steps we could utilize very simply with this tool to deploy more IP SLA VO tests. And so what we have here is the ability to select, do we want a jitter component, or you could think of the voice component of a video call. Maybe I'll put the DSCP value to that of the jitter component. I can then select what's the video test type that I'm going to select, whether it's a telepresence call, IPTV, or IP surveillance camera call. Those all can be tested, and they'll stream video with the applicable data rates that would equate to those types of video conversations. I'll click Next. I can then select what's the topology of my video rollout, whether it's going to be a hub and spoke configuration like with an MCU or a conference bridge or full mesh configuration. Next, I can select what devices do I want to participate in this test. And I could actually test a full WAN in one go, for example, or I could just test a subset of the network like I have here. If I click Next, we can then schedule the test. Usually these tests are stress tests, so you may or may not want to do these during production hours. And then finally, and most importantly, LiveAction will create and generate the applicable complex CLI configurations, so these become very easy to click and deploy and validate video in your environment. Now, the next tab I'm going to look at is the final tab in the latest addition to LiveAction, and that is our LAN tab. And this is our ability to track layer 2 network performance in our environment. And what I'm seeing here is I'm actually tracking VLAN 1. So visually in blue, I've highlighted my VLAN 1. I can see VLAN 1 is passing through all green interfaces. That looks good. I'm going to scroll over to a backbone network segment I've had highlighted. In this backbone, I have a 7600 as well as a 6500 switch, and then some 2960 access switches. And what I'm tracking here is, again, VLAN 1, and I can see it passing through several green interfaces. That's good. But notice how in this device it passes through an amber interface. And again, that's a performance problem with this layer 2 device. I'm going to double-click on this switch, and now I see the performance stats of this layer 2 device. So to the top of the screen are the trunk ports that are being monitored on this switch, and to the bottom of the screen are the access ports. On the trunk ports, I can see what VLANs are passing through which trunk. I can see the QoS trust type, the throughput measurements, as well as in amber, I can see the input drop. So I'm being visually notified about the performance issue with this switch. Now notice how there's also a show layer 2 QoS option on the switch. Well, this specific access switch actually does not have a QoS policy on it, but this 6500 device here right above it in my map does have a layer 2 QoS policy. Here's all the same type of statistics I was seeing before, but on my 6500. I'm going to click Show Layer 2 QoS, and we will actually show you and parse the hardware-based queuing performance of this Layer 2 device. And what I'm seeing here is a list of all of the ports that have QoS configured on them. I can see what's their switch port, their type, their trust type, the direction of the queue, what's the queue's threshold, etc. I can also see what's the cost map and the SCP map that makes up each queue. Now, if I wanted to, I could actually drill down and focus in on just the priority queues. So these would be the high priority LLQs that would be servicing my voice and potentially my video on the 6500 device. And here, at a glance, I understand which interfaces are having a QoS performance issue. I understand what is the drop rate based off the values in this column. And of course, LiveAction can alert us and notify us about the hardware-based queuing issues that I'm looking at right here. If we tried to analyze this by hand or via the CLI itself, we'd literally be scrolling through hundreds and hundreds of pages of static show commands to try to piece this together. I've never seen another tool do that. I'm going to zoom out now that I'm back to my map. I'm going to show you a third network segment. This is another LAN segment. And this LAN segment does not have VLAN 1 in it, but it does have VLAN 10. And here I'm tracking VLAN 10 through the network. I see all green interfaces. Green is good. But a feature that we have in LiveAction is the ability to visualize and show the spanning tree topology of a network. So here what I see in blue is the root bridge. The green arrows are your designated ports they're forwarding, and the red arrows are the block ports. And of course, when you have a topology change from a spanning tree perspective, LiveAction will redraw this map, and it can also alert you and notify you about that layer 2 condition that you very likely want to know exactly what happened and when did it happen. Now, another thing that I'm going to show you that we now have available in LiveAction is this. I'm looking at a layer 2 switch. It's actually a relatively new Cisco 3850 switch, and something that is now available in this switch type is a pre-embedded wireless controller. So what we're actually looking at is an iPad device that's connected wirelessly to an access point that we are not managing in LiveAction, but it's being controlled by the wireless controller embedded in this 3850. And what we can do is we can actually now gather both wired and wireless net flow data from your wireless controllers themselves. And let me show you what I mean by that. I'm going to double click on this device, and I'm going to go to my basic flow tab. And this is just traditional basic NetFlow version 9 in this instance that we're collecting on this 3850 switch. This is actually the wired side of the 3850 switch that we're seeing here, all fairly normal stats. But I'm going to change my view and make it be the wireless statistics that we're collecting on the switch. Notice how we see what looks like fairly traditional flow here, both source and destination IP addresses, port numbers, throughput measurements. Oh, we do see the application column, and the Cisco wireless team calls the application recognition on our wireless controllers AVC, and so we can see where our wireless user is utilizing YouTube, they're surfing the web, etc. So we have a very granular understanding of what our wireless users are doing. If I scroll all the way out to the right, I can see embedded in the wireless flow type that we're looking at, the wireless client's MAC address, the associated access point they're utilizing. I can also see what SSID they're connected on. And then finally, if your wireless controller is embedded or being managed by a Cisco ICE solution, you can also have the wireless user's username also embedded in the flow records. So you'll have a very granular understanding of who's using your wireless users, what applications are they using, as well as the volume of traffic that they're generating. So this is bringing us to the end of our demonstration and presentation today. I sure appreciate you joining us and taking a look at LiveAction. If you like what you've seen today, we have the ability to log into our website and download a free trial copy of LiveAction, and you can actually see all of the technologies that we highlighted for you today in your own network with our trial. And if you have any questions, either you would like to see more detailed demonstration of the product, or you'd like help as you set up and deploy a trial of LiveAction, feel free to reach out to us, and we are here to answer any questions you may have. Thank you so much for your time today.